Hi, I'm here on the Seattle waterfront to tell you what's new in Apache Flink 1.19. The Flink community has been hard at work over the past few releases, laying the groundwork for Flink 2.0, which should be ready for all of us to move in about a year from now. Flink 2.0 will be the first major release of Flink since the 1.0 release way back in 2016. Public interfaces can only be removed in a major release, so this is a significant opportunity to tear down and remove features and code that no longer serve the community well. Given the expected timing for this new major release, Flink 1.19 may be the last release to introduce new deprecations of features and options that will be removed. These 7 flips are all part of Flink 1.19. They focus on cleaning up and reorganizing some of the configuration options and preparing to tear down the last vestiges of the legacy SQL stack. Flink 1.19 marks the completion of an effort to improve how windows are supported in Flink SQL. This effort began with Flink 1.13, in which we introduced tumbling, hopping, and cumulating windows based on table-valued functions. Since then, Flink SQL has supported 2 schemes for windowing: a legacy approach based on grouping window aggregation, alongside this new approach based on window table-valued functions. This new approach to windowing is better in many ways. It's more expressive, it's more powerful, and it's more in line with the SQL standard. But the older scheme has been kept around, waiting for support for session windows based on table-valued functions. That wait is finally over. Session windows based on table-valued functions have landed in Flink 1.19. With this last gap in the feature set filled, the legacy window API can be removed in Flink 2.0. One of the most exciting new features in Flink 1.19 is the ability to apply windows to changelog streams in Flink SQL. Many developers have been frustrated when they discovered they couldn't window the output of a join or a group by, or a stream coming from Debezium. This limitation has now been lifted. Flip 400 introduces a new type of user-defined function to Flink SQL based on asynchronous calls to external systems. This allows for increased throughput when integrating with remote APIs without having to increase the query parallelism. One final update to Flink SQL comes with Flip 373. This makes it possible to configure different state time-to-live settings for individual SQL operators. Many SQL operators need to keep state, including aggregations and joins, and with this update, you can now use SQL hints to specify how long the state should be kept around for individual operators, rather than relying on a single setting for the entire Flink job. Next, we have a trio of flips that improve the observability of Flink's checkpointing and recovery mechanisms. Until now, teams operating Flink have relied on a combination of metrics and logging to diagnose problems relating to checkpointing and recovery. The addition of trace reporting based on OpenTelemetry provides better visibility into the behavior of these complex parts of Flink's runtime. Flip 366 cleans up an area prone to confuse and frustrate new Flink users. Until now, Flink has used a homegrown YAML parser with a number of idiosyncrasies. This flip brings a standard YAML parser into Flink that can be used to parse Flink's configuration file. Care has been taken to ensure backwards compatibility during the transition phase leading up to Flink 2.0. And finally, Flip 372 improves and finalizes the sync interface in a way that affects connectors such as the Iceberg sync. With these changes, syncs can now change both the type and number of messages being transported downstream. This is useful for syncs like Iceberg that want to group together the messages they receive into a single committable that can be shipped across more efficiently. I hope you've been inspired to build something new and amazing on top of Apache Flink. To learn more about this release, head on over to the Confluent blog or check out the full release notes for all the details.